So I'm happy to share a few of mine regarding data and open science. A short science CV for me, as Lena said, my area is machine learning and medical imaging. So I started with machine learning in Delft and then moved on more to the medical imaging side for my postdoc and tenure track position. And although I didn't get tenure, I think I did okay with my CV, with a number of publications and invited talks, also frequently about open science. But as you can imagine, with the CV and the associated CV of failures, it's often not the whole story. So I made my own version of this iceberg. Often you see the CV and all the rejections, but translating it into open science, you can see kind of the same. Okay, I'm doing open science and I'm invited to speak here, but actually on the bottom of it, there's also lots of mistakes. Well, and my own data horror stories. So starting with some stories from my PhD. So this is a machine learning PhD, and I'm working with data sets which are just basically like Excel sheets. It's already processed data, it's cleaned up, and it's available in a repository. It's easy to load, and I just need to do my own coding with it. So I was working with public data, publicly available MATLAB toolbox, and I could do my analysis in minutes, maybe hours. So that sounds actually like quite a perfect situation to create a nice, reproducible workflow, because I can share everything. There's nothing secret. But what ended up happening, of course, I was not really aware of this when I was doing it. Is, for example, when I switched to a new data set, I needed a little bit of adjustments in this toolbox I used. So what I just did is I just edited the code of the toolbox a little bit to adjust it to this new data. But then it turned out that if I wanted to rerun some experiments on the first data set, it didn't give me the same results anymore. And what's worse, when I had run many different results for many data sets, I did not know with which version of the toolbox I made those results, because it just saves an Excel sheet with the results, and I don't know where they come from. So in the end, I ended up rerunning the whole thing from scratch. And fortunately, that was possible because the analysis was quite quick. But I think it's not what you would like to have, and it's just wasteful as well of, you know, time and just the electricity needed for the computer to do so. So then I moved on to my postdoc. No, before that I needed to publish some papers to finish my PhD. And while writing these papers, I also did some procrastinating from the writing. And actually, that's how I got started with preprints. I think I was, you know, I wanted to create my own website and put something on it. And I knew that publishing papers would take quite a long time. So I heard about these preprints, and that seemed like a good idea. And then I also thought, well, I might as well maybe share some code since it's all public. That was actually inspired by this blog post by Matt Might about the CRAPL license. It is not a real license, but it basically encourages you to share your code as is, like without comments, doesn't matter how messy it is, but just do it. And I thought, okay, somebody gave me permission to just upload all the things as is. So I did, you know, I reran everything again, put it into a zip file and put it on my website, which is not like the best way to share code if you want people to reuse it, but it turned out still kind of effective because, you know, after a while I did get some emails from other PhD students working on this topic. So then I saw quite soon that there was actually impact from doing this sharing. So then I got my PhD, I moved on to my postdoc, and there I wasn't working with this nice Excel data anymore. I was working with 3D or 4D images, so 3D images in time. And yeah, the data was quite a bit larger, and it was also private data, which I couldn't just share as I liked. I also could not process it anymore on my own computer, so I needed to use a server which I connect to run my code. And because of this, the analysis would take like days or weeks rather. So I think due to this, I did make my code somewhat more robust, so I didn't have to do things all the time. But still, I don't think I had learned from my PhD yet, because basically I had almost all the same problems as before, but then squared, because now I had also this other server which had a different operating system and a different version of some toolboxes and software. So sometimes things that I did on my laptop to test out if my code is doing what I want, gave a different outcome on the server. And then also, this was data that was coming out of the clinic and didn't really have a README file. So sometimes, I was working maybe on a chest CT, so I have a 3D image of the lungs like this. But the orientation of the image was like every time in a different order. So one person was kind of like this, and the other one with the feet the other way. So I needed to look at it to sort of flip them myself. And I had this like long if statement, if it's scan 143, you should flip it, and otherwise not. Or I got an Excel sheet with some patient information. So with things like status, and there's like 0, 1, and -1. And people couldn't tell me what it means, these numbers. So in the end, due to these kind of things, my code was also quite specific to the exact data I was processing. So even though my methods were aimed at doing something general with chest CT images, I didn't think it was useful to share it because of these like eccentricities in the data. So moving on, I think when I started my tenure track, I made a few decisions to try to prevent these kind of problems. I think the main thing has been is that I've been working with students on data, and I'm trying to teach them from the start to kind of avoid these kind of mistakes. So we are doing. I've made a decision to only work on public data, which I mean has advantages in the sense that it's easy to share and process, but also kind of excludes me from some collaborations. But we try to make workflows which are easy to start doing, like what I call lazy GitHub. It's probably using only 10% of the functionality that GitHub offers, but it works for us to at least have versioning on the code. What I think is still difficult now, and where I run into problems, is deciding on procedures or conventions, like to how to do things with other people. Like at which point do we share data set, or how should we name file names that everybody else understands immediately what this is about? What should go into a README file for a student project? These things are still sort of questions I'm looking to answer. What is also still difficult are responses from academia, perhaps. Yeah, although I think science is more often on the agenda, I think it's still a little bit more so on paper than on what you're rewarded for. So people might say, oh, it's great, you tick the open science box, you tick the diversity box, we love this. Permanent contract, no. And the second thing is also within open science, I think there might be people who are who see it as like an all or nothing, and it's like, well, if you don't do all of these things and pre-registrations and registered reports and all these other, that's not how to do open science. You're not doing it correctly. And I think I haven't read it yet in detail, but I think this paper came out really recently, and it addresses some of these topics on how to deal with this. So yeah, I don't have all the answers, but here are some things that did help me improve with my open science journey. So the fighting ghosts part. I think the first tip is to start somewhere, but show up regularly and just do the thing. So maybe you can just start with preprints, for example. And you should try to build this into a habit, like into your workflow. This is not a one-time thing that you do, but something that you do, every week or every month. It's a bit similar with doing exercise, maybe. If you want to, get better at running, probably the best thing you can do is just go out running a couple of times per week. And definitely you don't need to first buy professional shoes and have a whole plan. You just start doing. So what helps for me is when I accept a project, giving a talk, I already, when accepting it, create things for myself to do on my list, like sharing the slides afterwards. Second tip is to find a team. Team science sounds good to me. So yeah, find some accountability and support. So for me, it's helped a lot to work together with students, because I feel responsible to teach them about these things. But I think also if you're just working on your own projects, you can find various online communities with people who are interested in doing this better, and to like learn together about all these things. I think there's lots of places where you can do this, but I wanted to mention specifically two of them. One is the Turing Way, which is an open source book for reproducible science, and it's basically a book that everybody can contribute to on GitHub, and it's very welcoming to newcomers. So you can join it without really knowing anything about GitHub or how to code. You can write parts of the book about different topics. It's very nice. And another one is Open Life Science, which is an initiative which also has a mentorship program. So you can sign up and you will be matched with a mentor who will like help you take some open science steps. So also shout out to Kirsty Whitaker, who I think is often involved in these kind of projects. I don't know if you've heard of her, but she's a great person to follow, like on Twitter, if you are interested in this space. And finally, so to mention, both of these have Slack groups which you can join, and then you can also talk to like lots of other people involved in these kind of initiatives. So my last tip is you should reward yourself. So although being recognized for sharing your data, that's like a very long-term thing and will likely not happen immediately, or maybe at all. This is hard to predict. So you need something more shorter term to feel good about what you're doing. So I think one way to maybe do this is just track your own metrics over time, like how many things have I shared, or how many people have I helped. I quite like Impact Story, so it's something I think that integrates with ORCID, and it looks like how many of your publications can be found online, or what kind of age Teenagers can read the abstracts of your papers, which is kind of cool. Yeah, so there are various ways you can track your own achievements. But besides that, of course, every time you finish a project successfully, whether it's a preprint or fighting some ghosts, you can also do a little dance. That's all I wanted to share with you today. Thanks for your attention.